Now let's go on and do some sensitivity analyses. I'm going to do methodological sensitivities where these are of interest to decision professionals that have to do with what method did we use, and then I'm going to do some golfing sensitivities that have to do with golfing skill levels. So let's go on to the second methodological sensitivity. What if instead of using the whole shot pattern, many decision analysts would ordinarily gravitate toward assigning 25, 50, 20 probabilities to each of these branches, and then just using that 9-branch pattern to come up with the best aim point. And that does work well for many problems. It does not work at all well for this problem. In fact, it would give you the wrong answer. It would give you the answer that would say the best aim point is directly at the hole. And that aim point, as we know, is 2 strokes worse than aiming at the best location for an 18-hole round. Why does it get you the wrong answer? Well, first of all, none of these points are in the bunker, so you have 0 probability of going into the bunker, but also 25% of them, 50% times 50%, are both on target, distance-wise and directional-wise, which means you've got a 25% of getting a hole-in-one. Well, that, of course, is ridiculous. Chance of a hole-in-one is, even for a skilled golfer, is less than 1 in 1,000, maybe even 1 in 10,000. So that method would not be a good method to use for this application. Another question is, well, what if we just, why do we need all these QPDs, even though they're easier to use? Why shouldn't we just use a traditional distribution like the multivariate normal distribution? Well, I plugged one in and I use the same means and variances and so forth as in Messaday and the same correlation coefficient. But the multivariate normal distribution produces a somewhat different answer. It's not a terribly different answer, but it's not a very good answer. And the bottom line is, not only is it not as good an answer, it's also not as an authentic representation, because the normal distribution multivariate normal incorrectly assumes that a given distance long is equally likely as the same distance short. So it's both harder to use and not as accurate. Might as well not use it. Might as well use what we have just presented here. Now let's go to some golf sensitivities. These are important from a golf perspective. What I have here is the base case 1090 range plus or minus 10 yards. What if you were a better golfer than that, plus or minus 5 yards? I don't know that there are any golfers in the world, actually, that could hit 80% of their shots from 160 yards within plus or minus 5 yards. Maybe there are a few pros at the top of their game, but this would be an extreme situation where somebody is actually that good. If you were that good, however, the best aim point would move. You'd just be 1 yard left to the target instead of 3 yards left to the target, because you get more birdies that way and you've got very few shots that are going to go into the hazard. What if you're a less skilled golfer? What if your 1090 range is plus or minus 15 yards? Well, in that case, you need to buy it. Your best aim point is to target where you're aiming farther from the hazard. And in this case, it turns out to be about 6 yards from the hazard instead of 3. What if, now this is a pretty wild golfer, this is a high handicapper. What if your shot dispersion pattern is such that 10% of your shots go farther right than 20 yards and 10% of your shots go farther left than 20 yards? If that's the case, your best aim point is over here, short left of the green. So the bottom line is, with greater shot dispersion, you would play more conservatively with respect to the hazard. I would note that wet and dry course conditions can reduce or increase shot dispersion. So it's not just a matter of golfer skill level. And also golfer skill level, with less skill, you'd probably have higher expected strokes to hole out. These results would not change if the higher expected strokes to hole out from every location is proportional. But if you were a terrible bunker player, for example, and you're here in this group, and you're a terrible bunker player and you frequently blade shots out of the bunker into the hazard, well, then of course you'd want to aim farther away from the bunker. So down here might actually be your best choice. So this all gets tailored to a golfer skill level. Are there situations where you should play more conservatively? The answer is yes, and this is where you would take risk aversion into account. And the golfers here will know what I'm talking about. But if you're playing match play, where only winning, tying, or losing the hole counts and not your absolute score, and your opponent hits his or her first shot into the hazard, and now it's your turn to tee off, well, your aim point is likely, your best aim point is likely to be more conservative and aim short and left of the green, leaving yourself an easy choice, because that way you'll both maximize your probability of winning the hole, given that your opponent's already in the hazard, and minimize your probability of losing it. So risk aversion can indeed come into play. Another question might be, well, what if the pin, instead of being on the front right, is on the back left of the green? Well, the back left of the green is far enough away from the hazard and the bunker that at that point you might as well aim directly at the hole. So, and that's true for a very wide range of shot dispersion patterns. It's not nearly dependent on golfer skill level as is the best aim point when the pin is on the front right. Okay, so in terms of conclusions, just say a couple of summarizing things here before we go to questions and answers. We've introduced practical methods for constructing and validating multivariate probability distributions using QPDs, 2 methods. We've introduced a novel approach using decision analysis to determining golf aim point strategy. The whole idea is aim better, score better, which looks like it'd be 2+ strokes per round, according to the quantification I've done. No improvement in physical capability required. What are the ultimate goals here? One of my ultimate goals in doing this research is to make shape flexible, continuous, multivariate probability distributions easy and effective to use in practice. As I said at the beginning, most people don't use them. They've just been too hard. Now we can just parameterize them with these intuitive 9 points, or it could be 16 points, or however many points you want. But with the intuitive, easy parameterization and simple equations, they should be easy to use. And the second thing we're trying to do is provide golfers with insights to enhance their performance and enjoyment of the game. We hope this research will be viewed as a positive contribution to both. There are a number of resources available. If you download this presentation, any of these links here are clickable. There's excellent opportunities to learn more about metalog distributions and indeed QPDs more broadly. There are multiple books that deal with golf strategies besides Mark Brody's groundbreaking book. And as I say, the whole world of this is moving extremely rapidly with apps that are available on your phone, online coaching. Ones that I found to be particularly useful are Decade Golf, Imagine Golf, and Top Speed Golf. These are all excellent according to your interest. So with that, I would like to close the presentation. A warm thank you to all of you professors, practitioners, and golfers and golf coaches and golf teachers out there. Thank you for joining me in this webinar. And what I'd like to now do is turn it back over to our moderator, Jay Anderson, for the question and answer period.